Now, emotional lives are just as complex. Emotions like happiness, sadness, anxiety, or even aggression are governed by the brain's incredible theory of emotions and cognitive appraisal. Think of emotion as your brain's way of sending you a quick alert, like an adrenaline rush when you're startled or feeling anxious before a big test. Sometimes emotional responses can spiral into mood disorders, like depression or anxiety disorders, even psychiatric hallucinations or delusions, if things get really out of whack. But it's not all doom and gloom. Your brain has an amazing capacity called cognitive reserve, which helps protect against some of these issues. Cognitive functions like problem solving, episodic memory, visual spatial ability, and executive function, think of these as your brain superpowers, are vital for everyday life. When these skills decline, perhaps due to cerebrovascular disease or hippocampal atrophy, life can feel a bit more challenging. And let's not forget about sleep disturbances, family conflicts, or material problems. These are like pesky bugs that can make your mental health even trickier. On the cellular level, things get even more interesting. Neurons communicate via synapses, those tiny junctions between presynaptic and postsynaptic terminals, and rely on proteins like synaptic vesicles, synapse-associated proteins, and enzymes such as protein kinase C and cyclic AMP. When these processes go awry due to synaptic disruption or protein misfolding, it can lead to neurodegeneration, as seen with caspases triggering apoptosis or programmed cell death. In neurodegenerative diseases, abnormal protein fragments like amyloid precursor proteins and enzymes like neprilysin, an amyloid-degrading enzyme, can cause synaptic pathologies, disrupting neural networks in the hippocampus, neocortex, amygdala, and cerebellum. These changes impair learning, memory, and neuroplasticity, the brain's ability to adapt and grow. It's like trying to update a computer with bad software. And speaking of plasticity, intracellular signaling pathways involving calcium regulation, protein kinases, and second messengers like phospholipids and cyclic AMP are crucial for long-term potentiation, the foundation of learning and memory. When these pathways become overactive or dysfunctional, it can dampen memory formation or cause learning deficits. In the realm of neurotransmitters, molecules like glutamate via NMDA and AMPA receptors, dopamine, serotonin, and GABA keep the brain symphony playing smoothly. Disruptions here can lead to overreactivity or underactivity, affecting everything from recognition memory to emotional regulation. Finally, the brain's response to stress and injury involves heat shock proteins, annexins, and other cellular defenders that help maintain neuronal health. When these systems falter, it can trigger apoptosis or other forms of cell death, contributing to neurodegeneration. So whether it's a family conflict, a stressful day, or a neurodegenerative condition, your brain's intricate web of proteins, receptors, and signaling pathways work tirelessly to keep you functioning. And understand these tiny but mighty processes helps us appreciate just how resilient and sometimes vulnerable our incredible brains truly are. Stay curious, stay kind, and take good care of that marvelous mind of yours.